turn it over to Dave.
By the way, Dave,
Oh,
Larson, you
yeah.
do need to mute your mic when you're not talking. There's a lot of
Okay.
background noise coming through.
Okay. Well, this week or last week, my wife fell and fractured her knee, and I was in the ER with her during this meeting last week. So sorry about that. And so that's about it for me. I've been trying to maintain my radios. With the weird space weather, it's hard to tell if things are working correctly or not. So I've been working with Michael Howen to keep everything going. That's about it for me. Next on the list is Nathaniel, W2NAF.
Thank you, Dave. I have been keeping very busy working on revising this paper. It's taking much longer time than I would hope, but I do think it's going in a very positive direction, and I think it will come through. So I've been spending multiple hours on it each day trying to get these plots to work and get them just right. So um, that's where most of my time has been going. And then, as I said, there's a lot of positive news in terms of the grants. It's looking like the Daisy 2 has been recommended, and this Antarctic proposal is being recommended. So, hopefully that'll all actually go through smoothly, and we're really looking forward to it. Back to net.
Okay. Sorry about the background noise. The Zoom people decided to make me upgrade just as I was logging in. So I have to sit down and figure that out. Next on the list is Dave, KD0EAG. Go ahead, Dave.
Hello, everybody. I've been doing a number of small things. Mike Cowan has been helping me with some RX-888 stuff. I've been writing some code. I've been messing about just generally, and but nothing really exciting to to report. I did wanted to be sure everyone is aware there is not a recorded version of last week's session because neither Dave nor Nathaniel was available, and so we didn't have anyone who could record, turn on recording. So last week's conversation, but it was a fairly lightly attended, there were some good things talked about, but not everybody was there. So anyway, that's it for me. Thank you.
Okay. Next on the list is Joe, W7LUX. Go ahead, Joe.
Good evening, all. Been fighting short-term and longer-term power outages here and getting the great receivers back working again, along with all of the computers and clocks in the house. And we're also seem to be getting hit with a lot of injuries to knees and hips out here in this area. And a hip injury is kind of serious to those of us who gained lots of years of experience. So we're kind of watching our step very carefully. Thank you, Dave.
Tell me about it.
Yes, my wife has had a hip replacement a couple years ago, so she wasn't expecting to have another injury, but it happens. Next on the list is Scott Newell. Scott, you're still mic muted? And then we have David N1HAC. Go ahead, David.
Good evening, everyone. Well, we've been dodging the floods over here. And very interesting weather down below. We've been getting isolated flash floods with everyone else in near drought. So, such is life in New England. And yeah, of course, we've got a very active geomagnetic storm ongoing. I saw maybe a little bit of aurora last night, but not so much from here. And of course, the KP equals 8 happened during the day today. Hopefully it'll continue, though it seems to be waning right now. I'll just mention one thing. I did get a newer RX-888, which does happen to be the black circuit board. All of my previous ones are the other circuit board. This one, I noticed there are a couple of extra features in it, like a bias T jumper, and the VCO has a pop-off cap, so you can actually get to it without having to unsolder things. We may have a discussion on all of this later on, but thought I'd bring that up. And very good to hear about the grants coming through. The ones I'm working off right now are pretty much at their end. So, but we are still working on our AM Doppler system and getting a lot more of them out and running. So back to Net.
Okay. Next on the list is Dave New, N8 SBE. Go ahead.
Yes, hi everybody. I'm still just working on coming up to speed on all the projects that are going on here, but and just like others have stated, we've had a big G4 geomagnetic storm in the last 12 hours, and so after we kind of dispense with everything else and get into the regular, random discussion at the end of the thing, I would like to hear what other people's experience have been with that so far. That's it.
Oh, wait. Okay. Then next on the list is Phil, K9Q. Go ahead, Phil.
Hi, Dave. You should probably put out the list on the chat site so we can know who's on deck, so just a suggestion. Anyway,
What I do is I pull up the participant list and go in generally in the order that it is on the side of the
yeah, but is that the same as as what I see?
I don't know.
Because when I look at the participant list, I'm at the top. So
Yeah, they don't make it easy to kind of share that information either. There's no like convenient way to
Yeah.
copy and paste it, unfortunately.
yeah, I would just find it easier if I knew when I was about to go up, so I wouldn't like step out of the room and go to the bathroom or something like
Yeah.
right. But anyway, just a comment.
Okay.
Not much to report here. Most of my work on KNIQ radio in the last 2 weeks has been on the FM demodulator, PL tone decoders, receiver voting, stuff like that. Nothing really relevant to HF. So I don't really have too much to report this week. Go ahead.
Okay. I've been working on one little problem with how to build an ID .text direct file. I built an ID.txt file for my area for 2 meters stuff, and it's an interesting task trying to put that file together.
Yeah, the ID stuff is really just a quick hack that I threw in just because it looked cool, but it clearly is very labor intensive to create such a thing. It would be wonderful if somebody would take on the job of automating that for a given area. I mean, for example, it really needs to have repeaters indexed by PL tone, is not just frequency. Here in Southern California, that would be very useful. So yeah, there's lots to be done. So if you're volunteering,
well, I might. We'll see.
Okay.
Anyway, let's go on down the list. Next is Bill Engelke. Go ahead, Bill.
Thanks, Dave. Yeah, we had the we had the Leonids meteor shower that peaked last night. Saw a few. We know we're kind of in a dark location here, so it's fairly easy to see them. So, and work some meteor scatter on 6 meters. Scott Newell, N5 TNL advised me yesterday that there was a problem with the SSL certificate on the personal space weather station network server. And I prompted our IT people to fix that this morning. So that was taken care of. Thanks to Scott for that. also been working with some image classification. I think we've got image classification on the some of the data that Nathaniel was showing at the beginning of this telco. It's possible to look at those heat maps and use machine learning to determine the probability that there is LSTID activity in the image. And so we can combine that with some other things to do some automated detection. So that's coming along. We actually got that working like this morning. Preparing for the Huntsville Hamfest coming up this upcoming weekend. I'm going to be in and out a lot over the course of the next month or so because I got some vacation coming up, and I will be also out a lot due to I sing with an organization called Apprentice Concert Chorale, and I did not make it to tonight's rehearsal, but I probably will be attending those from now until about the Christmas show. Anyway, so that's what's going on here. Back to Ned.
Okay, next on the list is Dave, WB9YIG. Go ahead, Dave.
Oh, thanks, Dave. I think is Dave a requirement on the you gotta have a name,
Well,
Dave?
we have a large quantity of Daves in the group, so it's the, I think, overwhelming first name.
That's fine.
Dave, instead of Dave's not here, Dave is here.
Yes.
Where he
Duplexer Ferrari Peter and I have finally come to an understanding. It took about 6 hours to get it tuned, but it's finally at least talking well. And this morning on the Indiana Digital Traffic Net on 40 meters, it was just about impossible to even get halfway across the state of Indiana.
Yeah.
It was just dead in a hammer. But that's about all. Back to Ned.
Okay. Let's see. Next on the list would be Tom, N5EG.
Good evening, Dave. I
Surprised
have to
you.
get faster. I've got to get faster at those buttons. That's just no two ways about it. Light week, not much on the project. A lot of other things going on, and so I'm going to be going to have about 3 or 4 light weeks until a couple things get sorted out. Back to the group.
Okay. Next on the list is another Dave, W6OQ. Go ahead.
Yeah, hi from Los Angeles. I'm just here trying to pick up on what's happening, figure out if there's anything I can do to help. So that's what I'm doing.
Very good. Next on the list is Bob, N5BRG. Go ahead, Bob.
Hello, everyone. I spending my time this past week or so working on my Cosmic Watch muon detectors. I want to get those online as part of my observing stuff here. And I've got 4 meteor cameras here running now, and I'm collecting data on meteors coming in. And I posted a link in the chat. If anybody's interested, they can see the activity that's reported. There's a lot of clouds around various parts of the country last night.
Are you seeing the shower, Bob? Are you seeing the ongoing meteor shower?
Yeah, about 2 days ago, 3 days ago, I was seeing several hundred meteors a night. So it was amazing. I think it wasn't as strong last night because of the cloud activity, but it is just amazing.
Cool, you should publish this.
It's mostly dust-sized particles, I think, coming in, but not quite as many fireballs involved. But that's
Wait,
all
are you
I
looking
have.
at radio or optical?
Optical.
Oh, optical. Oh, okay.
With some low-cost cameras, and in that thing that I posted there, you can get a link back into a wiki that describes it. And I would encourage other people to consider putting up one of these cameras and feeding data into that network also. It's pretty interesting. That's all I have, Dave.
Very good. Next on the list is Jim, K4BSE. Go ahead, Jim.
Good evening. Still not a whole lot of ham radio activities here, but boy, the ionosphere was busy last night. Wow. That's about as disrupted as I've seen it, both on 10 and 15 megahertz, and just a little bit less on 5 megahertz. So not a whole lot here right now. Bands have not been too great. Back to net.
Okay. Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. It's been a bit of a busy past 2 weeks in terms of natural radio emissions. We if we look at the thumbnails of the captured natural radio emissions, we can see August 6th and August 5th. These very long dispersion whistlers. And they sound actually quite nice. The system captured them pretty well. And one of the things that I'm interested in is why these whistlers are long dispersion as opposed to the ones in April. So that's a interesting question. But I'm glad that we got these whistlers, and I'm hoping for more because usually after geomagnetic activity is when you tend to get more whistlers. So I'm kind of hoping. There was a weaker storm last week, and I think this is what came of it. So hopefully there's some thunderstorms that will generate some nice whistlers that can be detected up here. And with this geomagnetic activity, so locally there was a weak auroral glow in the area last night, and there also was quite a there was some activity regarding with the with Navy VLF transmitters. This one, for example, if it ever shows up here, stop sharing. Whoops. Oh, sorry about that. This one, for example, this is the this is a this is a plot of whoops. This is I apologize for the mix-up here. So this is a plot of NML. What you're seeing. So the bottom stack plot is amplitude, and the plot of the middle is absolute phase. And you'll notice the amplitude during that night, last night, that it's kind of a little gnarly. And if you look at the absolute phase, it's also a little crazy. Normally this doesn't happen. At night the absolute phase kind of settles down, but during auroral activity, for whatever reason, and I'm not sure why this happens, but at night, possibly with the E layer, you see these short-term perturbations in the amplitude. So this is really interesting. What causes this? Why? Because what I wanted to show was a quiet plot, which is, let's see, the
where is NML, by the way?
NML is North Dakota.
Thank you.
And what frequency?
25.2 kilohertz. So this is no. Everything gets all messed up here. So anyway, on a quiet plot, yeah, here we go. So this is NML. So what I showed was last night was the UT day yesterday, which was August 12th. This is the UT day August 10th, and you'll notice here is that the amplitude is a little it's much more settled. This is kind of the normal variation that you see at nighttime. And if you look at the absolute phase, also much more settled, much more quiet. This is normally what you see. You're also seeing during the day. This is a little tiny solar flare. You know, there's some up here too. But at nighttime, it's you know, kind of settled down. So this is an interesting effect that I noticed someone else pointed out in one of the VLF Facebook groups that I'm on. You know, what's going on here? You know, like the plot looks, you know, a little bit more noisy. So this is an interesting effect when we have higher KP indexes. This tends to happen. So this also happened May 10th and 11th as well.
You're in Pennsylvania, right?
Yes. Yes.
So 1000 is your local dawn?
Yeah.
Okay.
Yep. Yeah. Yep. So yeah, the local dawn is around 10. So you can see when the D layer starts to form, there's the effect of the change in absolute phase and the change in amplitude. This is 108, you know, basically it's about 180-degree phase shift. But yeah, this is that's a normal effect every dawn and dusk.
Okay.
But
When you say absolute phase, you're keeping track of possible complete rotations?
Yeah, so what absolute phase is it measures the carrier phase and compares it to the a reference phase, which is derived from
Right.
the 1 pulse per second signal from the GPS.
I see. So okay, so you are accounting if it were to slip an entire cycle, you would see that.
Yes. Yep.
Okay.
Yeah. So this is actually pretty handy. Carrier phase is a very handy measurement that, you know, allows you to see information that you normally wouldn't see because you obviously don't have the phase information at the transmitter. So it's the next best thing is a you know, reference phase from the GPS. But anyway, yeah, this is very interesting, and I also saw it in NAA as well at 24 kilohertz. The same, you know, noisy looking the same noisy looking plot, the same noisy looking phase plot as well during auroral activity. This is a interesting thing that I would eventually like to figure out. Lastly, just a bit of an anecdote. I had a cable guy here to fix an issue with my signal levels, having intermittent problems with my internet, And I was talking to him about whistlers, and I even let him listen to some samples of the captured whistlers. So he was actually pretty impressed. He was a technical guy too, obviously. So we kind of enjoyed talking about that, and he was really interested in this. That's all I have. Back to the net.
Okay. Next on the list is Clint Turner. Go ahead, Clint.
Evening. Don't have a whole lot to add here, just kind of maintaining things until we do other projects and make more things to break. I guess talking about severe weather, both ionospheric and in the whatever the part of the atmosphere we live in. It's been interesting to watch the effects of seeing everything disappear, at least for a while, above 10 megahertz earlier today on the web SDRs, which makes you want to double check that nothing's actually broken. But inevitably, you can see some really weak FT8 carriers stick out of the noise. So I guess that's the bellwether these days. And some insane high winds and extreme rainfall, short duration rainfall events, which is typical of the monsoon season here in Utah. So been dealing with that. And fortunately, nothing's broken either at the SDR side or here. So anyway, back to the group.
Okay. Yeah, I was going to ask if any antennas were breaking, so you answered the question. Next on the list is Jay Schwartz, WB8 SBI. Go ahead, Jay.
Yeah, good evening, everybody. Haven't been checking, have missed a few meetings here due to schedule conflicts. Nothing really ham radio wise special going on. Still plowing ahead with my cybersecurity stuff for the Society of Automotive Engineers. Dave, your presence there is on my team is still welcome in on my cybersecurity electric vehicle team. We still appreciate your participation. And in amateur radio stuff, AMSAT just announced that at the end of October, their annual meeting and space symposium, the last weekend in October in Tampa, Florida, for those that are interested. I'm assuming also it will be live streamed at that time. Otherwise, nothing really new here. So 7-3 to on, I'll just be sitting back reading the mail.
Okay. And next on the list, I'm going to call on Tom Yarnish. Go ahead.
Hi, I've been away from things for a while, recovering from COVID. Right now, I'm just more or less a fly on the wall, but I maintain a 888 site here for Rob AI6VN to do his development work on Whisper Demon, and gradually setting up for some 6-meter experiments here with the local group, both I think 2-minute whisper and then FST4W, if we can get enough stations going. I'm really interested to hear about the new RX888. I haven't seen the latest version. I have an older one here that has been running for some time and has been rock stable after a few modifications. And I kind of think maybe I could add another one to the fleet. But I'd like to hear more about it sometime. If anybody knows where to get them and whether or not it's worth the money, if it's really any better than the old ones. Other than that, not much to say. I'm just sitting on the sidelines here, watching the fireworks here with the new CME event and everything. So that's provided a lot of discussion locally. And otherwise, I'm still slightly in the recovery phase from COVID, but see the light at the end of the tunnel and looking forward to more amateur radio junk on the desk. That's about it. Back to Ned.
Okay, thanks. Glad to hear you're getting better. Next on the list is Rob. Robinette. Go ahead, Rob. If he's there. Nope, no Rob. There's two Robs on there. And I assume they're both Rob Robinette.
Yeah, Rob is putting on his headphones as we speak.
Oh, okay.
Yeah, I'm upstairs doing kitchen stuff. So I just have a major thing I've been working on is deploying Whisper Demon 3.0. So there's lots and lots of sites now, Whisper Demon sites reporting FT4 and FT8 to PSK Reporter. So including yours, for example, Bill, has been upgraded. Phil, you've been upgraded, so you're now on, you now have reports on the PSK Reporter site. So and Nathaniel, when you work, when your system works, you'll get up there again. Anyway, I need to take a break here. If we go back, I'll talk about a bunch of other stuff, but that's the major focus, my focus right now. I'll be lurking for a while, then I'll be back.
Okay, well, now we're open for general discussion.
The weekend races nets were difficult. The 75 meters was weak and 40 meters didn't work anywhere near for the nearby communications. And that bothers me a great deal because we have a critical application coming up in later September where we have to provide communications with a site that's about 35 miles away from me, and it's being difficult. It's in a radio hole. There's no VHF or UHF coverage there whatsoever. And it's being a real challenging problem, especially with all the changes in the ionosphere.
Yeah, it's rare that I can't hear at least one WWV station solidly, but that's been the case a lot lately.
So for something 35 miles away, I take it using either 80 or 160?
Well, 80 has been marginal, and 160 is, we've never tried it. It's, well, actually we have, but I don't think 160 would do. If 80 isn't very good, 160 is going to be worse.
Yeah, it does have even higher absorption than 40.
Yes.
Right, but you have exemplars in the form of myriad low power and medium power AM broadcast stations to study afar.
A big problem is the requirements for a gigantic antenna for 160.
And probably a lot of power too.
Well, that's true too. And I could suggest 630 meters, but that won't help you.
We've used 60 meters in the past for medium distance with some success.
I said 630.
Oh, yeah, I'm on that, but
yes, I am as well. But I don't think I've worked you though. But okay, I'm rather surprised 80 goes away. We used to use it routinely for boat-to-boat coverage in the Colorado and Green River gorges with mobile antennas on boats, and it almost always worked out to a radius of about 200 miles during the daytime.
Yeah.
Wow.
Well, we've been having the same problem in New England as Joe was saying. You have use for it for Aries, but it's just not doing its thing, and even 40 is unreliable.
In the past, we've started on 75 and moved to 40. And boy, this time almost no one could hear anyone else. So had to go back to 75. And of course, as the sun heats up the D layer, that goes downhill quickly. 200 miles, that's a long way, Clint.
These were 100-watt radios on Hustlers and mag loops. We used it from 1960 to we stopped using the loops in 2000. And the only time it didn't work was when something really strange happened. you know, and it was usually only a few hours. And of course, it only worked during the middle of the day. But these are the ultimate in NVIS antennas, because we had to get out of quarter, half mile deep gorges to talk to each other.
75-meter mag loops, that's a pretty good size structure.
4 feet. Yeah, with vacuum variables. I mean, they were probably 20% efficient at best, but I mean, they worked phenomenally well for what they were. I mean, one of our numbers ran the simulations for both propagation and all that, and pretty much they're the ultimate NVIS when mounted above a really good ground plane like water on an aluminum boat. But anyway, I yeah, I know what you mean. That can be a tough thing.
Well, we've got two projections in between, and so we have a somewhat similar situation to what you have. We'll work at it.
The other thing that worked that we've used for long distance is 6-meter sideband, which is more approachable because almost everybody owns a radio that does 100 watts on 6, and that is somewhat immune to obstacles compared to 2 and 70 centimeters especially.
Our problem is the location has a cliff, rise, whatever you want to call it, to the south. And then there's the highest point in Arizona in between. And then there's a much lower, several thousand feet lower peak. So we've got 3 obstacles in between, and it's being a problem. I don't know that 6 might work. I just don't know. Anyway, it's a big deal.
When I lived in Flag, Phoenix could routinely be worked on 2 meters any time of day. So it might be worth trying it just for yucks.
But it's a much clearer path to Phoenix than it is up to this location. These people put their aid stations in low elevations where water used to collect for tanks to feed the horses for the old stagecoach service. So
well,
I'm working on it.
Yep.
I have a question for Nathaniel on the stuff you were showing earlier. I'm just curious, how did you decide which station you selected to show data for? Or does your software allow you to do them all if you wanted to?
We're actually throwing all of the data together from the entire United States.
Oh, wow.
So we're looking at, we just take all the RBN, all the PSK reporter, all the WhisperNet data over the entire United States. We find the midpoints of each communication, and then we bin that in a 2D bin as a function of distance between transmitter and receiver and time. And we calculate a 2D histogram. And then you can actually see the bottom, that first top skip distance vary with time.
Okay, thank you.
Clint, a quick question. Those mag loops you were using, were they single turn or multi-turn?
They were single turn. Give me a moment and I can come up with a picture of them. But anyway, yeah. Yeah, they were single turn with I don't know about I don't know about a little more than a meter in diameter, and then there's a smaller loop, maybe about 10-12 inches in diameter for the could be rotated for critical coupling, and then typically a 10K 1000 puff vacuum variable was used to resonate them. They were at the point that you could only tune your radio while talking. You couldn't key down with an AM and effectively key the radio because the audio bandwidth 2.4 kilohertz audio bandwidth would inevitably result in a 1.5 to 1 VSWR just because of the occupied bandwidth.
Let me make a comment here, Dave, KV0S. I noticed that on my end, we're locked on your screen, and I don't know if others are seeing that, but if you step away, which you sometimes do at this time, others may not be able to share their screens.
I think he's having issues with the new version of Zoom because
Yeah.
we're hearing a lot of audio here, which he didn't have last time he was on.
I also don't see his screen being shared, so it's
Oh,
not.
I am here.
Nor I.
Yeah, I don't know what I've been trying to figure out the controls on this new version. I may have to reinstall it.
Do you have more than one microphone there, like one on the computer you're using?
No, I'm using a headset.
Tap your headset mic. I thought so. You're not using that. You're using your
Okay.
laptop mic. That's why you're
Okay.
picking up noise.
Okay. Well, I don't have a laptop, so I'll have to figure
There's
out what
another
it
mic in the room somewhere because we did.
Yep.
I heard no thudding noise.
Did you hear anything on that one? No, that's a
Yes.
different machine.
Well, I heard a knocking of a. Nope.
So is it unique to me that I'm stuck on your screen and not just following the speaker?
You can.
I'm
Yeah,
not
he's
seeing
not.
that.
I think you. I think you can select if you want to be on somebody all the time. If you really
Oh,
want.
Bob, you may have his window pinned.
I have it on speaker, but maybe there is a pin somewhere that I'm overlooking.
It would say remove pin somewhere in the window.
Yeah. Right click on. Right click on.
I got you. Okay, thank you. I got it.
Does that help?
Yeah.
Sorry.
That sounds better, Dave.
Well, good.
So in the Zoom audio settings, if you had prior set it up for like music or anything like that, because you were trying to like send something out that had CW or something in it, that will also tend to pick up a bunch of room noise. So then you should go back when you get done and set it back to the noise reduction setting.
Well, the real sound is the one you're talking about.
Yeah.
By default, that is not on, but I don't think he's. Oops. I don't think he's on. I don't think he's on his headset mic yet.
Right. But most everybody should be on Zoom background noise removal auto. And then if you need to share something with sound in it that Zoom is knocking out, you can change that to one of the other settings like live performance audio.
They have some
Yeah,
new AI features they're rolling out too, Zoom does, which could be playing a havoc here.
We ran into a new one on another Zoom meeting today. Spotlight focus, which we'd never seen before. Where if somebody moves, this was wide angle camera, somebody moves, it focuses right on them, whether it's actually a person or a leg. It would even focus on individual chairs and blur everything else out. We couldn't figure out what setting was doing that.
It sounds like a Sony cam we tested it many years ago that had a face finder, but it also zoomed in on certain women's chests, let's say.
Oh dear.
So we had we never could use it.
Zoom now has a thing in their audio for spatial audio, which is on your receiving side. It makes voices sound like they're coming from the position of each person on the screen. I tried it out and then turned it off right away. It's annoying.
Talk about soundstage.
I think there's quite a few variants of Zoom being used here.
Okay, another basic physics question. How does a geomagnetic storm wreck on a certain propagation? I know how a solar flare does it, but how does the storm do it?
So when you have a geomagnetic storm, you're going to have changes in the ionospheric densities. So at the beginning of the storm, you're going to end up having you might have a period of positive ionospheric densities, increased ionospheric densities, and then shortly thereafter that, like the whole magnetosphere, the ionosphere is just going to drain out in terms of electron density.
Okay, now what happens? Is the D layer affected by this, or is it too low?
I think it's mostly the upper layers, the E and the F.
So the D
Yeah.
layer does its usual thing of forming in the
Well,
daytime.
remember, aurora comes from electron precipitation.
Yeah.
So that's ionizing the polar regions, and
Right.
presumed that, and then that starts bouncing around.
But my understanding is a geomagnetic storm tends to affect the night side of the planet more than the day side.
Right.
And then a solar flare, though, affects only the day side and affects the D layer.
Right. That's a direct, that was easy to understand, right? That's
Yeah.
just long wave X-rays or short X-rays and so forth, ionizing the D layer more than the
Yeah,
usual.
one thing that's interesting right now is that the storm is affecting, for me, the CHU propagation, and I'm hearing auroral warble on CHU. It's you usually get that on higher frequencies, but
Well, you're close enough to the pole that, you know.
well,
You're
I'm just saying that it's a short hop from Ottawa over to New Hampshire.
Yeah.
But yeah, the 3 megahertz is coming in fine. 7 megahertz has a nice warble on it.
Yeah.
And then the WWVs are, of course, all over the map. 10 megahertz is coming in and out, 15 in and out. I'm hearing Hawaii more than Colorado, but that's not that unusual for my spot.
So the storm basically just drains the upper layers, the ionosphere, the good layers, the ones we want.
It can.
Okay.
I'm gonna in a
Or
minute. I'm going
turns
to
an
show you.
absorptive.
Oh,
The weirdest thing is that ever since the May 10th storm, 25 megahertz has not been propagating right.
Yeah, I haven't heard WWV there in a long time. Nor do I hear much CB on 27 megahertz.
Yeah.
Yeah,
I've been
the 10
meaning
meter
to
band
ask.
hasn't been open. Yeah.
I've been meaning to ask WWV if their 25 megahertz is on low power or something, because I do hear it occasionally. It's just never been
Well,
this
you
strong.
can find out if it's on the air by going to Glenn Omar's local receiver.
Well, true.
Yeah.
Um,
Well, I wouldn't tell you it was a low power.
but being experimental, they're not going to report problems with it.
I understand. Somebody told me the WWVB is operating on half power.
That's
yeah,
correct.
that's been true since a windstorm took down part of their
Yeah,
antenna.
what was it? April 8th, I think. Windstorm took down one corner of one of the antennas, so they're down 3 dB.
Is that the old WWVB, WWVL antenna that?
Right. I think
Yeah.
it was the old VL
Yeah.
that happened to be the one went down. And they're waiting because they would run up the tower themselves and fix it in an instant, but the bean counters won't let them.
Yeah.
They have to wait till September to get someone to climb the tower for them.
That's changed, you know. In ARDC, we look at a lot of grants, and an awful lot of grants that we see, a large chunk, there's a large line item for tower work, and
Yeah.
that's changed from what it would have been, you know, decades ago.
Right. Well, we're running into that too for our repeater here locally. We're 300 feet up a 400-foot tower, and we're not allowed to climb the tower ourselves anymore.
Well, I certainly don't want to climb one, but
Yeah. Well, we've got some very experienced tower climbers, but they don't maintain their bonding, and so not allowed on the tower.
no.
A lot of that around here is due to people being way older than I am that used to climb the towers.
Yeah.
so Phil.
Yeah.
This is a paper that my colleague Evan Thomas did a few years ago. It's about the geomagnetic storm response to GPS to electron content in North America.
Okay.
And he does a few really nice things in here. One thing he does is he makes a superposed epoch analysis plot of the SIMH parameter. So instead of using KP, a lot of space physicists use either SIMH or something called DST, Disturbance Storm Time Index, to tell you when you are with a geomagnetic storm. And this is also measured using ground magnetometers. So right at 0, this is the beginning of the storm. -1 is an hour before the storm, and then this is, I'm sorry, an hour before the storm. and then an hour after the storm, 2 hours, and 3 hours. And so what you see with SIMH is that before the storm, SIMH is pretty much zero. And then you see right at the beginning of the storm an increase in SIMH. That's when there's what's called the sudden storm commencement, and the bow shock of the magnetosphere is pushed closer to the Earth. That increases the ring current around the Earth, or I'm sorry, that when the magnetosphere gets pushed closer to the Earth, that causes the magnetometers on the ground around the equator to sense this positive increase in the magnetic field. And then as the storm continues, the ring current going around the Earth enhances, and that enhanced ring current actually causes a decrease in this parameter.
Is that a magnitude measure?
This is in
Not a vector.
nanoteslas.
Okay,
So
so
this
that's
is
a magnitude. That's a magnitude, not a vector.
That's yes.
Okay.
It is well,
And
it's this particular magnitude is measured in the north-south component of the ground magnetometers.
and
Wouldn't
I
that
see
be
the
So-
the horizontal is in days, not hours.
Wouldn't that be the
I'm
differential?
sorry, yes, you're right. It is
Yeah.
in days, not hours.
Yeah, right.
Yes.
Because there would normally be a field. I mean, what's the Earth's magnetic field normally?
It's
20,000.
like
20,000.
60,000 at the equator, and I'm sorry, 30,000 at the equator and 60,000 at the poles.
Nanotesla?
Nanoteslas. Yeah,
Okay.
nanoteslas.
So this
Yeah.
this is just the
Yeah.
nominal. The zero is the nominal.
Yeah,
Right.
so a flare is only a 1 or 2 hour thing, but a geomagnetic storm is a 2 or 3 day thing.
Right,
Yes.
right.
Yeah.
Right.
Yeah. And so he's looked at 139 storms here. So every single trace here is a different storm, and he's just overplotted 139 of them, and he's keyed them all off on this sudden storm commencement.
Are these
So
all over the world?
yes, the SIMH is a global parameter, so
Yeah.
it's measured using a network of ground magnetometers nearish the equator, and they're spread out throughout in local times, so they are spread
Okay.
out around the globe. So this is
Right.
a global parameter.
Right.
And then the thick black line in the middle is the average behavior, and then the upper one is the upper quartile, and the lower one's the lower quartile.
Okay.
So you can see that you get this bump called the sudden storm commencement, and then as the storm progresses, this SIMH parameter decreases, and the storm is at its maximum when the SIMH is lowest, and then it goes into recovery as it gets closer to zero.
Okay.
Okay. So the other thing he does in this paper that's really nice is he gives you these maps here. So let's just look at one of these maps. This is relative total electron content measured by GPS receivers on the ground.
Hence the limit is 60 some north. Okay.
Yeah. And so each of these, the very top is at 12 magnetic local time, so this is essentially noon. Then on the bottom is midnight, so it's away from the sun. Then on the right hand side is dawn, 6 magnetic local time, and on the left is dusk, 18 magnetic local time.
Okay.
Okay, and now red colors are total electron content that are increased compared to normal, and blue colors are total electron content that are decreased compared to
I
normal.
see. Okay.
And so now he's showing this is hours. So this really is hours from the start of the geomagnetic storm.
Okay.
So you can see here at the beginning of the storm at 0 hours, there's a slight increase in the total electron content.
All the way around, not just at local noon.
That's right, all the way around. And
Yeah.
then that continues, and you do have more of an effect here at the night side, but it is still all the way around. And then after, say, 6 to 9 hours, you start to get into what's the negative phase of the storm. So that's where you see a decrease in total electron content. And that also has different effects, you know, depending on where
So
you are in the earth.
where are those particles gone? Do they precipitate into the atmosphere?
No, I think what happens is I think so the inner magnetosphere ends up I think it comes in. And so normally I think I think they actually escape out. I have to review that.
Well, I mean, there are
Yeah.
auroras, so some of them at
Yeah.
least are.
So some of it does precipitate, but I don't think that's the only thing that happens.
Somehow they get depleted. Okay. So
Yes. Yes,
the good
there's a
layers get depleted. All right.
right. And he makes these plots for different seasons. So this first one is this is on average for all 139 storms.
Uh-huh.
And then I think this is northern hemisphere only. And then this one is for only the summertime. So you can see the summer behaves a little bit differently.
Uh-huh.
And then this is only for winter storms.
Okay.
Oh yeah.
Yeah.
So he breaks it up by season. So I think Evan does a really nice job kind of laying out how these storms affect the ionosphere, both in terms of time relative to the start of the storm and also in terms of season and latitude and longitude. So I think you can access this for free. I can put the link in the
Oh,
chat
yeah,
here.
please. Yeah.
Yeah. And
So when the bands start to recover, they start to recover low to high. Yes, as the electron content starts to go back up, you would expect the MOF to start increasing.
Yes.
So okay. So the highest bands will be the last to recover.
Right.
Okay.
So back to that picture of by the hour, the circular plots of the Earth by the hour.
Yeah.
Roll up there for those for me for a second. Let me ask you a question.
Chat. Okay.
Got it.
Okay, I put it in the chat.
Thank you.
Okay.
So like on this one right here, if you had hour, like he's probably averaging over the full hour to get that 0 hour plot. Is that right, you think, or some increment of
Yeah,
time?
there's some increment of averaging for each of these plots.
So if you had a
And
time
also,
increment of -1 hour up there, would it be back to the blue like the 33 hour plot?
either the blue or like it should be
Somewhere in
closer to
between?
like white, I think,
Right.
because yeah, a very pale color.
Right. Okay. Good.
All right. I
I also have a paper that I did that looked at a geomagnetic storm in the ham radio bands in September of 2017.
So do we see enhancement in the higher bands right at the beginning of the storm?
It was actually very tough to, I was amazed at how difficult it was to see the signatures in the ham radio bands for the geomagnetic storm. And so I
We
didn't
have all that
have,
raw data now, right? I mean,
oh
it's
yeah,
there.
and we
Let's
can
see
look
it.
at this. We can look at this more. So one thing, it's very easy to see the effects of solar flares. So here's a solar flare.
Yeah,
You just
solar
see
flares I
boom.
understand. Yeah.
Those are easy. But
Yeah.
the geomagnetic storms, they were really tough. So this is one plot that I came up with. Let's see if I can make this bigger.
One comment I heard from several people, Nathaniel, was warbling sounds, as in aurora.
That would make sense.
And my old original grape had wild swings in the frequency during that storm, about 10 hours worth. It was just way over the ±1 hertz limit of the chart.
I think there's a lot to look at. So this is, here's the geomagnetic storm that happened on September 7th, September 8th, 2017. And so here you can see that KP got up to like between 8 and 9 over this time. And then here's that sim H parameter we were looking at before. So you can see there's that sudden storm commencement. That's where it went down. That's the biggest part of the storm. It started recovering. There's actually another storm right here. So you see it go down again and then it recovers. And if you look, this is the same format of ham radio plot I was showing earlier. It's basically a heat map of the amount of the communications. This is from RBN and Whisper, and this is now looking at global data. So going from say 0 to 10,000 kilometers, and we're now showing it on a scale of days on the x-axis here. So we're going from September 6th through September 12th. So we're looking at 12 days here. I'm sorry, 6 days, and we're looking at 10,000 kilometers of range. And if you plot this all out, you can see the different bands. Here's 10 meters, 15, 20, 40, 80, and 160. And you can see the diurnal day-night behavior of each of the bands. And, if you look at where the storm happens, if you don't have these lines here, I actually found it kind of hard to see a really dramatic difference between 20 and 40 meters before the storm and 20 and 40 meters when the storm was going on. Like you can kind of see it, but it wasn't anywhere near as dramatic as I thought it should be.
Yeah, we know that the bands are crappy when this happens. So
yeah,
but which bands? I mean, it looks like 15 meters got hit pretty good, and 10 somewhat.
Yeah.
So it looks like there's a kind of a critical frequency, I think.
But it wasn't nearly as obvious to me as it was for the solar flares.
Yeah, right.
And the other thing I did was I calculated in the next plot here.
Well, solar flares are easy, right? Increases delayer ionization, so it's going to, up the, music frequency. I mean, that part we understand, right?
Right.
Yeah, and it recovers pretty rapidly.
So this plot, what I did was I calculated a background. I calculated a background like quiet day, average quiet day behavior for the bands. I found like 100 days where it was like very low geomagnetic activity. KP was like 1 or something like that, or 0. And I used that to create an average behavior for each of the bands. And then I calculated a z-score and I plotted that here. So now you can see like red is above average and blue is below average. And when you calculate it and look at it that way, then you can see, a real drop off in 7 and 14 megahertz.
Yeah.
But there were actually like, I still don't understand these anomalies I saw up in 28 megahertz. So I think it's really interesting to look at. And I think there's a lot more to be learned if we keep looking at this data.
Well, your data is not stationary, right? I mean, you're getting more and more data all the time. So
that's true.
How are you allowing for that?
Well, I didn't have to in this particular study.
Okay.
Because I only looked at one day, and then for my quiet days, I picked 100 quiet days within the same year. So for that particular year, it was fine. But yeah, certainly, if you're going to look at longer term, I have some examples of that too, from it was EGU back when I think it was AGU 2021 when it was really COVID was really still going. Or is it AGU 2020? Yeah, so December 2020.
So just looking at the 40-meter waterfall right now, it seems to be fairly normal for this time of the evening. And that's, within a day of when we had this big geomagnetic storm. Although the signals might be a little lower because what I don't see is a lot of the international broadcast carriers on here that I normally see.
Yeah.
Hmm.
Log in.
So maybe the propagation on 40 meters might be overall somewhat lower, but it's the band seems to be fairly active.
Nothing on 27 megahertz other than my TCXO and my
Yeah.
yeah.
Well, that's been my thing too. I haven't seen anything on 10 meters for quite some time.
Usually I'll see more on 27 megahertz before I see more on 10 meters.
Yeah.
Here's RBN and WhisperNet from 2009 up through 2020. And yeah, you can really see the growth in the data here.
Mm-hmm.
This is F10.7, so here you can see the solar cycle. So here's like solar max over here. And so
Yeah.
you can really see 10 meters light up. And you can see 15 meters light up as well. But even as you go past the solar cycle, those drop off. But you can really see these other bands increase, probably not just because people are going down to those bands, but also because there's an increase in the amount of data coming in.
Yeah.
And this doesn't even include PSK reporters. So like now, I think Bill Engelke will tell you with FT8 that just last few years, it's just exploded in terms of the amount of data.
Well, I can tell you pretty well that just by listening to the FT8 frequencies on the bands, you can tell if there's anything going on. Because that's where it'll show up first, even before CW or sideband activity does.
Yeah.
One of these years, I got to do HFDL, because that might be another interesting source of propagation data. A lot of places that we hams don't go or can't go. It's airliners over the Arctic and over the oceans.
Yeah.
And they conveniently transmit positions and reception reports. So
What caused that weak line right down the center of your data?
The weak line right down the center.
Yeah, there was a
right
like
here.
Yeah.
That there has to be some
no, the horizontal line.
Oh, that horizontal line?
Yeah, in the middle. Yeah.
Oh,
that.
that I believe is a distribution of amateur radio operators and geography. So we actually did a little simulation of that. So we said, okay, if most of your operators are in the US or in Europe, if you just calculate what's the probability of any station here talking to any station there and vice versa, you come up with a distribution that looks like this. And you can see that there's a drop off right at like 4,000 kilometers that matches that really well.
Yep. Yeah, we just don't have a lot of stations in the middle of the Atlantic.
Yeah.
That's what HFDL would do for you.
Yeah, to fill in that gap.
Yeah, and the polar regions, at least the North Pole region.
Yeah.
Yeah, so the Thomas et al. Paper up here talks specifically about GPS. So what happens at GPS frequencies do not necessarily correlate with what happens at HF frequencies.
Well, it tells you what the electron content is, right?
Well, it gives GPS as an integrated value of the electron content.
Right, along the path. Yeah.
Right, along the path. So the HF is sensitive to gradients in the bottom side electron density, but there actually is a pretty good correlation in from what I've seen. So for instance, in another paper I did where I was looking at these large scale traveling ionospheric disturbances.
Well, maybe saying correlation was the wrong thing. What I'm trying to say is the effect seems to be much more pronounced at those frequencies.
At the
at the GPS frequencies.
Well, it's L-band.
Yeah.
It's well above the max usable frequency, but it's low enough that you see these effects.
Yeah, yeah.
High enough, you're not going to see any. I mean, you know how it's measured, right?
Right.
Like the different delays between L1 and L2 or whatever other frequencies they have now.
But here you can see this is the HF 20 meter data again. And there you can see the oscillation down at the bottom, the traveling atmospheric disturbance. Here's the GPS data. If you take an average of that in the box, it matches this oscillation very well.
But that TID is not necessarily a result of a geomagnetic storm, right?
Not necessarily. This one I think is, but it doesn't have to be.
Yeah.
This particular one, I believe, is a result of a geomagnetic storm.
Oh, I was going to ask you, I saw super down there. What are you going to use for antennas in Antarctica?
Right now I'm planning on using like active magnetic loops. But
okay, that somebody has to install.
Yes.
Okay. Yeah. I had a friend who spent a year down there. I mean, nothing is easy down there.
No.
Installing anything is not easy. Yeah.
Yes.
And all the radio equipment would be inside in a controlled space.
Well, yeah, but antennas have to be usually installed outdoors. So
right. But the radio stuff, the electronics do funny things when it gets real cold too.
Oh yeah, sure. But you gotta have an antenna for it, and somebody's got to install that. And
so do you have a public link to this particular paper that you're showing us?
Yeah.
So Nathaniel, your antenna, that loop antenna that you shipped up to Canada, is in service. So you're going to have, however much, you're going to have a winter season to see how well it works.
Which I'm really excited about, and I think this is really good because what we're going to be able to do, now that we have the Ellesmere Island one, and maybe we can put some things up in Svalbard too, because I know Hyomin has some stuff going on up there. I think we will, it'll be nice to do some conjugate studies between the Arctic and the Antarctic. And we'll be able to get these stations in both places. Rob, so and I think this will also give us a chance to, work out our hardware a little bit more. In the Antarctic proposal, I said that we'd be using EDIS USRPs, which are those kind of expensive radios that we were talking about a couple weeks ago. So I think we can use those, but I think there's some opportunity to both work with those and then also compare try using the RX 888 and see how they do, or get the devise something new as well.
Well, cooling shouldn't be a problem.
No. Although
it's getting tougher.
I know.
Yeah.
I understand there is one building down there that actually has to be actively cooled. It's one of the radio telescopes, and they have a server room, and it actually has to be actively cooled. It's the only room on the whole station like that. It's generates so much heat.
Rob.
Yes.
If I were to get you or one of your programmers one of these EDIS USRPs, would they be willing to develop make it work with Whisper Demon and K9Q radio?
I think it's well, I don't know what it has a USB interface, and they have a driver. I did Gamal, I think, pointed me at the USPV site, and it appeared like there was a driver.
Actually, Nathaniel, wouldn't this would be a Ethernet one?
Right.
Yeah, it'd be
Yeah.
Ethernet.
Yeah, it's Ethernet. Yeah.
Probably
It's
10
it's
gig.
Ethernet.
It's 10 gig Ethernet, right?
I think it's gig Ethernet.
Yeah, big gig.
Well, it's too slow. I've never actually. I mean, I know of Edis Research. I mean, I just had dinner with them the other night, but and I know what their boxes do, but they've always been too expensive for me.
Yeah.
But I understand it. The standard of the newer ones is 10 gig.
Mm.
I mean, 1 gig is not enough even for an RX 888.
Yeah.
I thought they had a USB interface, but maybe that's not.
That's
There
a
is
different
a
one.
version
That's
that
for consumers. That's for consumers.
well, no, there is a version of it, and that's also been cloned a lot. But there's an earlier version of the Ethernet box that we've been using that is USB, but it does not seem to be on the market anymore.
Well, if the USRP has a what do you call that little socket where you slide fiber transceivers, SFP, that has an SFP socket for 10 gig, I would strongly recommend using that because now you can use fiber to isolate everything.
Mm-hmm.
Strongly recommend that.
Well, anyway, I don't think it's an issue for me. Of course, as long as it's really between Phil and the radio to get it working. I can Whisper Demon can work with any radio that K9Q can talk to, which are many. I mean,
Yeah.
Yeah.
Somebody get me USRP and I could probably write a driver for it. I mean, I don't know what kind of problems I'd run into, but I'd have to get a computer that has 10 gig E on it for one thing.
Yeah.
It just doesn't seem like a productive to work on a device where the interface is fundamentally a choke point.
Yeah.
Well, like USB, yeah.
What's what goes over? I miss what goes over the USB port of that device.
It doesn't have a USB port. It's just
It's out of
Yeah.
focus, Daniel.
Okay.
Oops. Now you can't see it at all, but I can.
Okay, it's a little out of focus, but I still
I see that. Okay.
Can't. Well,
It is. Well, I get it. Yeah. How do you get it? You have a gig.
MIMO.
Gigabit Ethernet on an N210 is gigabit.
Okay.
Yeah, I'm
so
pretty sure it's
that's a
gigabit.
low end. That must be a low end unit.
Well,
for $3,500 doesn't
old.
strike me as low end.
Yeah, that's low. No, that's low end for Edis Research. Yeah.
They're 10, 15 years old.
Yeah.
Yeah, I had one of these at my work before, but we weren't trying to do extremely wide banded stuff.
Yeah.
We were
Of course,
working with
yeah. If you're just observing HF, it's not like we really need a whole lot anyway.
Well, I was working with 900 megahertz spread spectrum devices.
Yeah. Okay. All right. Yeah.
That's a different.
It's different.
Yeah.
Yeah.
I'm not aware that there's any device like other than the 888 that's that we can that covers the whole of the HF band.
Yeah, I'm just nervous about USB 3 and device like that in a high-end research project.
Well, I think that's why we would go with these.
Exactly.
Yeah. Yeah, the USRP is internally 66 megahertz sampling, but I guess you can't get it through the band. It has a FPGA inside that you're intended to down sample it.
Yeah.
And can you I mean, I don't know. Can you program this thing to just give me raw samples?
Yes.
Okay.
Yeah, that's what we usually do, but
yeah, okay.
But you can only get 900 megabits of effective throughput, I mean, theoretically. So your sample rate has to be more like 30 mega samples. So that doesn't. Boy, we really need the chameleon or whatever, Clementine. This every the RX 888 is a unique but such a fragile device to be working with.
Yeah.
Oh, so if you get the B210 board only, it comes with the USB 3.0 super speed.
Yeah.
I thought Kamal has had a USB 3 interface on the one he has there in Cairo. So
USB 3 is either 5 or 10, right?
He says he put a note in the chat that we've got 2 Gamal sessions.
That's listed as a low cost SDR. It goes for $2,100.
Yeah, well, it's low cost by their standards.
Yeah, but it does have a USB 3.0 super speed interface for what that's worth.
And is there more than one super speed? I think it's what, either 5 or 10, right?
It's 5.
5, okay.
It's almost certainly got the same interface we're using.
Yeah. Which makes me a little nervous, I just don't totally trust it.
Yeah.
Boy, you haven't. I mean, I have not encountered any transfer problems. You at least you haven't reported any, and Whispered Demon would notice if samples were getting dropped. So of all the problems that I've been encountering with deployments, the USB interface has not been one of them. Well, apart from the fact that, other than the fact that it kind of disappears occasionally, like it has at Nathaniel's. Have you tried replugging your 888, Nathaniel?
Yeah, I tried. So I was gonna ask. You said the Bodner's not working right?
No. Well, I don't know. I'm just guessing. The syslog from Radio D says that it says it can't be found. Well, let me go try. You're plugged in.
No.
Hold on. I'm logged onto your machine here. Hold on a second.
Because no, it can find. Last we had it, it could find the RX 888, but you said that the Bodner wasn't working right for some reason.
No, I can't say that it was the Bogner. All I can say is that Phil's Radio D logs to the syslog, and it reported the clock was 100 megabit clock, which of course is not the clock rate that you've configured it for.
No.
Which
Yeah, we've seen that several times when the 888's outputting no data at all. K9Q radio reports random numbers around 100 meg.
Yeah, let's see. I'm just logged onto your machine right now, and I mean this is what Radio D is showing. Here's what it looks like. Hold on, share screen. Let's see, where is it? Yeah, here, Nathaniel. This is your. It's the middle. Well, the top here. I'm sharing several windows here, but this window, as you see here, Phil is printing out the rate right here.
Yeah.
And so let me stop him. I can stop the. Okay, and then I'll just start him again.
Remember what that is? It's just a gross check against the time of day clock, which is going to be less accurate.
Yeah.
Just to tell you if it's way off. It's not going to.
You also need missing a. Got to do. You have to wait a while. Now, Phil, I've noticed that many sites. So I've been installing this on many sites in the last week. On many of them, I do not see any mention of the clock rate. That line does not. I always.
Oh no, it won't unless it's grossly off.
So what's your tolerance before you print the that it's off?
I don't know. Look at the code.
Okay, but I was wondering whether you had removed the message or that I just have a lot of sites.
No. I deliberately took it out unless it is grossly off. I mean, I don't want to log with routine everything is okay messages.
Okay. Well, that's what I expect. Well, we have to wait a minute here before you.
I count samples over a minute to get just
So 3921. There it comes. There's the first minute, and you see it's off. Now, I think that's unlikely. That's the Bogner. I think that's more likely that what you're seeing is that either
there's often a startup transient in the first minute, so you can just ignore that.
Yeah, I haven't really seen that much, but now I don't have on yours. It's if I install this thing, I could look at what how your Bogner is set up. Is but because and see what make sure I know that up at VY0 ERC, I was like it wasn't running, and I was getting these numbers, and Pierre, who was up there at Elsmer, said, "Well, I set it up. The Bogner is set for 27 megahertz." And I put in this, there's a Linux command line Linux utility to talk to Bogners. And I looked at it and he had set it for 270 megahertz. So the Bogner user interface makes it really easy because they have you enter the output frequency to the hertz. It's pretty easy to add or subtract a zero digit and get off by an order of magnitude from so
Sure.
I'm let's see, I'd have to download this code and install stuff, but you might just pull the Bogner off and plug it into your desktop machine and run the Bogner's utility for your machine. If you have a PC, they have a
I
whatever
do.
PC.
We've configured it that way before. Does it sometimes forget?
I have had that problem at once at KFS where that it just we lost there was a power outage, and when it came back up, the Bogner's apparently, well, two things happened. One is that both of the Bogner's had the wrong frequencies coming out, and then I have a dual output Bogner, and one of its two outputs was dead. And I haven't been out there to figure out. I did try to reprogram it, but
I was going to say, I do know that if the RX-888 is loses its clock, it will continue to run, but at the wrong frequency.
Yeah, well, this is what it's doing is we're talking to the
Right.
the driver's
That's what I'm
talking
saying
to
is that the
the
the 5351 seems
Yeah,
to
yeah.
still
you
put
can-
out a frequency, but it's
not
what you expect.
I don't know what those 92 megahertz come from.
Well, I mean, the way you would know is bring up a spectrum, a waterfall spectrum, if that's available, with hooked up to a known antenna and see where WWV really ends up.
Yeah.
I've never heard anything, but I've never really looked. I mean, I just hear noise.
Well, usually it does nothing. But the other thing that can happen is if the internal and external clock are applied at the same time, which you can do if you mess up the jumpering. This is one of the reasons why on all my 888s I do have a enable disable switch, so I can quickly do a sanity check whether or not the 888's dead or if it's a problem with the external clock.
Yeah, I kind of I gave up on the external switch because I kept when I was screwing and plugging in the USBs, I kept flipping the switch in the wrong direction.
That's a raw problem.
Yeah, well, I think I'm fairly attentive to those things, and even so, in the heat, when you're under time pressure, sitting out there at KPH, and they're about to close the building, you can overlook the fact that you've brushed the switch in the wrong direction. So I've given up on that, and I've just I just removed the jumpers.
Yeah, I've also been placing my on-off enable switches on the edge side of the USB 3 connector, so you actually have to reach in there with your finger to get
that
to it.
That would be.
Well, I'm hearing a lot of stuff here. I'm looking at PSK reporter. Wow.
I am
89, 83 reports from K9Q in the last 24 hours. Not bad.
I'm sorry, you're looking at your own.
Yeah, I'm looking at what you said. You installed it in my machine. Wasn't even aware of it.
Not even. Yeah, it's not even 24 hours. I put it in. I think this morning. So you're doing reasonably well. It's a. I saw PSK reporter. I don't. He has a statistics page, but my sense is that if you look back over the last week, as I've turned on more Whisper Demon sites, that the total number of spots per per second. Spots received went up from like 250 spots per second to him to more like 400. So I think that
I hope he can
uh,
handle it.
say that again.
You're gonna be throwing a lot of load on him. I hope he can handle it.
Well, I warned him, and Philip said, he said, "Oh, that's okay. We, his uploader, which he supplied, he has a. If you go to his GitHub page, he has the Linux PSK upload library.
Okay.
It's a one um, it's just one a Python script, but anyway, it goes in and it only uploads a spot if the transmitter hasn't been uploaded in the last 15 minutes.
Okay.
Rob,
So that's his. Yeah.
Here's my I have my Bodner connected to my Windows machine now.
Yeah, yeah.
So this is the configuration software.
Let's see. 27. Yeah, and you hit the set frequency again. You might just change it and set it again, change it to 28 and then change it back to 27. I think you can see how easy it is to type in 270 megahertz because
Definitely.
there's no commas in the, but I think you have 6 zeros there, right? So
1, 2, 3, 4, 5, 6.
yeah, you're not making Pierre's mistake.
Yeah.
And
You
well,
can, yeah, right. You can also change the output drive strength. Sometimes 32 milliamp is overdriving.
It doesn't, it's such that I've done this, and even under load, it surprises me. Okay, if you terminate the Bogner's output, it's a 50 ohm terminator, and I looked at it with my scope. Okay, you vary the output current, you would think, right? If you went from 32 mils to 16 mils, that the voltage would go down.
Very little difference.
There's very little difference. You can go from 8
yeah.
milliamps to 32 milliamps.
Right,
In terms of voltage, it makes no difference.
You run Ohm's law and you see a Y though.
What's that?
You run Ohm's law and you see a Y.
Does this look good, Rob?
Yeah, it looks like you have the right right.
So I can close. Yeah. So now I can close that and reconnect it to my
Yes, you can. Yeah, it looks like you have it set correctly. Now Michael reported to me. I guess he's not with us tonight. Maybe he's working.
He was still on shift.
Yeah. So he received a 888. One of his 888s would not, with Phil's adapter in it, would not lock up. And he got a replacement, bought another one, and it would not lock up. And so he removed the Paul's adapter isolation PC board and connected the Bogner up directly with a terminator on the outside. And they work. So it may be that you ought to consider, I don't know if there's a way. I was going to ask Paul if there's a way to jumper his board, because his board does provide ground isolation, which is a good thing.
Yeah, but does it provide at least a resistive DC termination on the 888 side?
Well, you'd have to look at I'd have to look at the schematic of his PC board to see if there's a way to jumper it in some way internally.
Because I mean, you can't just couple a capacitor onto a floating line.
Anyway, you need to look at his schematic to determine if the printed circuit board could be modified. The alternative is, to kludge up something, as I've done.
What are you thinking of modifying? What change?
I hit Paul's adapter card that goes inside the 888, the one.
Okay.
What would you change?
Well, so that it doesn't reduce the signal levels by 10 dB. So the Paul has designed it so that the
Right. Well,
that the output level is 200 millivolts peak to peak,
right.
and maybe that's a marginal level, and that there are some triple eights that need more than the 200 millivolts.
No,
Murphy
200
says,
millivolts is not, well, yeah, that
Murphy,
is low.
Murphy says that the newer 888s have protection on them already.
Yeah, actually, that's a good question why he reduces it to 200 millivolts, because the spec into the chip is 1 volt peak to peak. And it will take up to 1.5 volts.
Peak to peak,
and
plus
the,
and minus voltage. Is this plus and minus or 0 to?
Okay, I'm looking at Paul's schematic. It's 8.3 dB.
Yeah.
So
right. Well, there are a couple of things going on here.
that is not 200 millivolts.
Yeah, but first the input, the external input has back-to-back diodes on it, so it clips it at 0.7 volts plus and minus. If you're just going plus, it would be a 7-volt peak-to-peak clipped waveform, and it's capacitively coupled into the chip. So that would work. That's probably plenty of signal. But if he's got too much attenuation ahead of it, then it might be reduced from that. I haven't scoped it myself. I have one of his boards. I'll take a look at it.
Well,
but it's easy enough to change the resistors on it. They are surface mount, but we know how to do that.
that's a skill that I'm not particularly good at. But
No,
anyway, I think that we have this now that we have a larger sample size, maybe we need to review the the values.
Yeah.
And
the other
make
thing I'll say is I think the input circuit of the blackboards is the same. From a cursory examination, it appears not to have changed, but I'm going to double check that.
Yeah,
well, I don't have, unfortunately, by the way, I don't see. Why don't you, Nathaniel, why don't you replug the USB port, because I'm still seeing the same 93.
All right, so what I'm going to do is I've unplugged, let's see, I just unplugged the RX 888.
Yeah, and we
So
should see, there it goes, and I see it on, yeah.
Okay.
Yeah.
The log.
The Bodner is still plugged into the USB and its light is on. Do you want me to unplug that too?
No, I know. I think that's fine. You leave it alone.
Okay.
Now I just plug the 888 back in.
Okay.
Yeah,
The
just
888 is now plugged back in.
For reference, if you put 8 milliamps into a 50 ohm load, you only get 0.4 volts out of it.
That was not what I measured when I terminated the Bogner with a 50 ohm load.
Interesting.
Well, I mean, we do know that there's several 888 variants, because the one that I repaired for you, Rob, there's a DC connection between the external clock input pin and the external and the 5351.
Wow.
And also the BAT 99 is between the ground and the 3.3 volt.
That is different.
Right. So if you hook a Bodner right up to it with nothing, you get 3 volt or whatever output, the waveform unclipped that the Bodner produces. I was using my service monitor here to generate the signals when testing it, and so I know that the version, at least if what use based on it, you say there's several variants out there, because the one I have, the one Rob has, which is an older one, is definitely not the same as what you're describing, Dave.
Interesting. Okay.
Yes.
Well,
Yes.
all the ones I've looked at seem to have that same input structure, both purple board and blackboard.
Mm.
The most recent one, well, 2 of them I got from Illikitzer parts. So I know the source on those. And it's not the same place that everyone else is necessarily getting them. That's the problem with this Chinese open source stuff.
Yes, it sure is. It's
Can you post a link to the place you're talking about, Dave?
That I am?
Yeah.
Yes.
Helicopter parts or whatever.
Can I share the USRP 2900 image now?
yeah, go ahead, Kamal. This is
Yeah, please.
Okay.
If you can share a screen, we have to give them.
Here is it. This one I just found it
There you go. There you go.
in the lab of the university. Yeah.
Okay. All right.
So everything is clear right now. The band is a little bit far away, right?
yeah, that's very clear. That's
Yeah,
that's the
that's
front
very
of it. That's the RF input. We're most interested in the backside.
Yeah. Okay, that's okay. That one starts at 70 megahertz. So that
yeah,
one,
so that's not going to. Yeah, it's going to have to. But apparently,
yeah,
there's a
most of
different.
most of his devices are designed for VHF, UHF.
Yeah.
Yeah,
Yeah.
I'm not an expert in these things, but from talking to some people who do use them more, they basically said that the Edis N200 and N210 are really the only ones that do HF.
Yeah, and you have to
y-
get the right cards in them.
and you have to get the right cards, and they said they aren't really seeing Edis come out with new versions for HF, and that's what people are very worried about.
Yeah,
So
everything is this 70 megahertz and above.
I think ever since Edison was bought out by National Instruments, why things have gone downhill.
Yes.
Well, Matt himself has been working for Apple now for a couple of years. I had dinner with him a couple nights ago when he was in San Diego.
Yeah. Yeah, I think he jumped ship at about the right time.
Yeah, a while ago actually.
Okay, he's just
Well, one more reason why we need a Clementine. Even if it's just I think, if it's just a
You mean
clone of the
our own
AAA.
hardware you mean our own hardware we control is what you really
Yeah,
mean.
so we know with the source of it and the provenance of all the parts that in it.
Yeah, until some of the important parts go EOL, right? Of course.
That always happens, but
Yeah, right.
Then we would know the EOL and we'd be able to anticipate it. But it doesn't seem like the 22.8 is going away. So it's
I really am hoping that we can get some of our own hardware put together for this, because if we can, I think, as I said, the deployment for Antarctica isn't going to be for like 2 years at least. So there's a little bit of that might be good motivation to really help us get that together.
And when the time comes, shit down lots of spares.
Well,
yes.
I mean, if I were to design something that would go down there, it would be just in 2208, 5351, and an FX3, and nothing else. Nothing else. Because I can make my own damn gain and filter all day and night, and it does exactly what I want it to do, and the KISS principle applies. So,
well, what I'm kind of imagining is that maybe the first thing that goes down there is really kind of the really tried and true Edis USRP that's battle hardened and expensive, along with the computers. And then as we do develop these other systems, we can try putting those down there as well. And then if they do work better, eventually transition over to them. But if we're still having trouble with them, at least we have the Edises.
You can only ship once a year.
We don't have one working yet, though. So we don't. So you're postulating that the Edis would be reliable in an application that we've never used it in, and we don't even have one. So I think if you're gonna do that, it's timely to assemble the candidate parts, because at this point, I am pleased that, I'm thinking, I've got a year of experience now, runtime with multiple, half a dozen or a dozen B-Links, which is a little gaming computer, and I haven't had one failure on them.
Yeah.
And I know that my big Dell servers, managements are reporting internal failures, fan failures, and so on that are going on so they're such complex devices that I think that a better thing to do I mean, what I've done at KPH is do full-on redundancy, one-on-one. Have
Mhm.
two RX888s out of KPH. I have two 888s, each attached to a B-Link, sitting right next to each other off a passive RF splitter. And if
Mhm.
one goes down, I've still got the other one over there, and I've got and to me, you know, the one-to-one, and I'm doing the same thing. We're in the process of doing the same thing for the Whisper Daemon database servers.
Yeah.
Is we're going for one redundancy, hardware redundancy, at our new upload site. So um, I'm so I'm more inclined right now to say, put in redundancy. Don't depend upon any device, however well tested it
Yeah.
is, that it's gonna be a reliable long term. So that's what I wish we could do up at could have done up at
Alsamer.
Alsamer, but you know, it took 2 years to get a good, apparently reliable antenna up there. So anyway, that's my advice on this redundancy.
Yeah.
And everything in the Whisper Daemon world in terms of putting things up, you know, putting recording spots and everything, it's a triple redundancy on the hardware, the physical locations. We're going for 4 redundant locations for storing the data. And there's, you know, in contrast with WhisperNet, which has only one server, which dies and then takes the whole world down. So anyway, that's my advice is, but I really wish we could just focus on doing what Clint said. Let's just do the simplest. It seems like JLPCB, you could lay one of these things out and have JLPCB just do something that works with Franco's driver. You know?
Well, you need to more or less cut the Glenn's thing in half.
The what?
Glenn made a dual ADC version of something.
Well, he hasn't. But that's not his. That
doesn't use an FX3 though.
He hasn't. And he hasn't. That's not a product yet. He hasn't really designed that thing or fabricated it yet. That's what he wants. I think it'd be great if Glenn comes up with a design. That would be a great solution. Just go. You know, if you go to his site, you know, he's now put up all of his hardware designs are there. You can download them and drop it at JLPCB and order your own. I don't know if anybody's done it yet, but what he doesn't have is he doesn't have the SDR design.
Rob, did that fix the problem at all?
No, you haven't. Not you still have the 90 megahertz. So the only thing I could suggest is that you take the thing apart. I don't think do you have an external clock adapter and try connecting up the Bogner up directly?
I do have the external clock adapter that you gave me. I can't connect the Bodner up. You want me to connect the Bodner directly?
Well, yeah, you have to have the jumper that goes in, right? I mean, I'm talking about the internal connection to the external clock port inside the 888.
Yeah.
So you need to bring that out and plug the Bogner into it and put a terminator on it. Probably ought to have some kind of DC block, but I know mine ran for quite some time without any.
I mean, right now I have what you gave me. I have one that you modified that Paul Elliott modified with the breakout board that Paul Elliott made that goes between the RX888 and the Bodner.
I'm sorry, his printed circuit board I thought I gave you is one that goes internally.
No, it's an external one.
An external one. I don't remember what that one is. I don't remember.
If you throw a 10 dB pad on the 888 with just going into it, it'll work fine. I mean, that seems to be a very safe thing to do.
Well,
you can.
By the way, I only need to ask a brief question. Phil, is there a current fork somewhere of K9Q radio that does support the RSPs?
To report the or support. Oh, yeah. Well, actually, that is
That's Franco.
Franco's.
Yeah.
Okay, I was looking on Frank. Apparently, it's not on Franco's Git.
It is. It is. It is.
Oh, is it?
Yes, it is. It's there.
Okay.
And
One of
there's
these
a
days.
magic that you have to, you have to go to his. I'll take you there in a second. It's
Yeah, I got to merge in one of these years. I already merged in. He did a enhancement, the RSAAA driver that uses a tuner in the VH for the VHF UH input. But I merged it in, but I haven't actually tested it myself yet.
Right, because we're coming up with an application where, you know, I mean, does he interface with the open source Merix, or does he just did he hold his nose and just work with
he held his nose. He's using the API that's a closed source API. So you have to go through and download, install. You have to go to the.
I do that. I know. Our web.
Okay, you're not to do that. Okay, so once you do that, then
I tried that several times in the past, and it really gave me a bad.
Well, I in middle of last year, you had it worked before you made the big change to the kernel, and you still had the separate multicast at the full sample rate. It worked solid. I ran a like 200 channel 2-meter receiver on an RSP for 8 weeks, and I never had to do anything to it. It just ran.
Okay.
I filled up a third of a terabyte drive with audio files.
Okay.
So I mean, but yeah, okay. I just wanted to make sure that I just wanted to make sure.
I'm willing to merge it in as somebody else to do all the work. I mean, all the.
The problem I had with it is that, I mean, it's our. I tried to simplify the installation. If you have Whisper Daemon and you just specify K9Q radio, Whisper Daemon does all the installation, all the configuration. You don't have to touch anything. It treats it like Kiwi. It does all of that automatically. Right. But with the with other devices other than the 888, each one is different. So if you go, let's see, where is it?
I was looking for that.
Yeah,
I looked right through that because I was thinking that's not K9Q radio.
He doesn't mention it. So what you have to do is you have to no, let's see. Is this the one? Did I pick the wrong one?
I'm gonna have to say 73 for tonight, but thank you, everybody.
Okay. Good luck.
Thank you.
Nathaniel, if you open your thing, you can tell whether you've fixed it by looking at this log the way. So you bring up a terminal window.
Yeah.
Okay. And you just bring up a regular whoops, I popped out.
I think what I'll have to do, I'll have to get I don't think I'm going to be able to put significant time into this until after I get this paper published.
Okay.
So unfortunately, that's got to be the number one thing for me. But,
by the way, the transmitter is up and online. You know, it's the second most listened to beacon in the world.
Okay.
Behind WWV. It's number 2 in the world. So the
W3USR one.
Yeah, W3USR is if you go look at the top beacons list. Here's top beacons. You can see your number 2. There's WWV at now if you sort by the number of RAWs, you know, which is so you're the second in the list.
Huh.
How do you like that?
That's awesome.
Okay.
Okay.
There. So that one's working up.
Yeah. Hopefully over the next week we'll figure it out. But I just can't put dedicated time into it until I'm like.
I understand.
Yeah.
Yeah, it's okay. Your site is it'd be nice, but it's we have many sites around you that are also gathering data.
We definitely need to get it up though. So
okay.
All right. Thank you.
Take care. Yeah.
Okay.
Take care.
Bye.
Who runs WW0 WWV? Who runs that?
What's that?
The folks at WWV.
Yeah,
Yeah,
that's Dave Schwartz, who was with us earlier. That we installed that out